Hey guys, welcome back to the episode 3 of Circle series for JEE Mains and Advanced. I'm Abhinav. I've done both my bachelor's and master's in electrical engineering from IIT Kharagpur. So in the second episode, we have discussed the coordinates of point of tangency and the equation of tangents from an external point. So how do you find the equation of two tangents that are drawn from an external point to the circle and the length of the tangent from an external point and the equation of normal at a point on the circle. If a point on the circle is given, how do you find the equation of normal at that particular point? And similarly, equation of tangent at a particular point on the circle. We have covered all these concepts in episode 2. So if you want to understand any of these concepts, make sure you go back to episode 2 in this playlist and check it out. So in this episode, which is episode 3 of the series, we are going to discuss two important concepts and we are going to solve 3 questions. So the concepts that we are going to discuss are chord of contact and director circle. All right. So what is chord of contact? So you have a circle and from an external point P, you're drawing two tangents to this circle, which are T1 and T2. And the points of tangency are A and B. And the coordinates are given by A, B and C, D. Let the external point be x1, y1. So we will first derive the equation for this chord. So this is a chord of a circle, and since this chord is formed by joining the points of tangency, which are the contact points of the tangent with the circle, so this is called as chord of contact. So the task for us is to find the equation of this chord of contact. Do not treat all these things as concepts. Treat these things as different questions. So you're given a question and you're just solving it. So that is why I'm presenting all the proofs in my videos. Think of all these problems on your own before watching the solution or proof. All right. So the task is to find out the equation of this chord of contact. So let's do it. So now let us do it for the circle x square plus y square is equal to a square, and then we will generalize it for the general circle x square plus y square plus 2gx plus 2fy plus c is equal to 0. So first we will do it for this particular circle. Now the equation of tangent T1 can be written as T1. So I have derived like this is a point on the circle a, b. So equation of tangent at a point on a circle, we have derived it in episode 2. If you don't know how to write this equation, do check it out. This can be written as x1. Here x1 is a and y1. y1 is b is equals to a square. So okay, let this be r square. Since we are taking a here, so let us consider the radius of the circle as r. So this is r square. Similarly, the equation for the tangent T2 is cx plus dy is equal to r square. All right. Now, if you compare these two equations, the first equation, this tangent passes through this particular point. So you can write ax1 plus by1 is equals to r square. Similarly, the second tangent also passes through this particular point. So you can write cx1 plus dy1 is equal to r square. Now, carefully look at these two equations. So from here, you can conclude that, see, x1 is common in both the equations. So let us say if you consider this particular equation, xx1 plus y1 is equal to r square. If you consider this equation, so a comma b will be one solution to this equation. So from here we can conclude that a comma b is one solution to this equation, and from this particular equation we can conclude that c comma b d is another solution to this equation. And since this is a linear equation, equation of the straight line, and we know that these 2 points are passing through this particular equation, so we can conclude that this particular equation is the equation of this chord. So the equation of the chord is xx1 plus y1 is equal to r square. So this is simply x1 plus y1 minus r square is equal to 0. T is equals to 0. Alright. The equation of the tangent to the circle at a given point is also same. But there your x1, y1 are the points of contacts. But here in this case your x1, y1 are the coordinates of the point, external point from which the tangents are drawn. So you should be careful about it. So the equation of the tangent at a point is t is equal to 0, and equation of the chord of contact is also t is equal to 0, but your x1, y1 in each case are different. In case of tangent, it is point of tangency, the coordinates of point of tangency, and in case of chord of contact, it is the coordinates of external point. So now let us go ahead and solve two questions based on this. Okay, this is your first question. If the chord of contact of tangents drawn from an external point h comma k. So this is your external point. So this is one tangent t1 and this is another tangent t2. And your AB is the chord of contact. The equation of the circle is given and they are saying that the chord of contact subtends right angle at the center. So this is center, let's say. So in this case, center is origin and this chord of contact subtends 90 degrees at the center. So this particular angle is 90 degrees. All right. So now we have to prove that this happens. So if this is 90 degrees, since radius and tangent are perpendicular to each other, this angle is also 90 degrees. And this angle is also 90 degrees by the same logic. Since POAB is a quadrilateral and three angles are 90 degrees, so this angle should also be 90 degrees. All right, this should also be 90 degrees. Now the equation of the circle is given. So x square plus y square is equal to a square. So this length is simply a, which is your radius. This is a and this is also a. And since this angle is 90 degrees, by Pythagoras theorem, we can conclude that this length is root 2a. So we can conclude that AB is equal to square root of 2a. Now, let us find out PA. So what is the length of PA? So length of PA is simply square root of S1. So we have derived this in the second episode. If you don't know how to derive this, just go there and check. So this is simply square root of h square plus k square minus a square. All right. But since this is root 2a, since this length is root 2a and this is a right angle triangle, and these two lengths are equal because they are the tangents drawn from the external point. So this length and this length will be equal, and this is root 2a. So this is hypotenuse of triangle PAB. So therefore, if this is root 2a, this should be a. All right. So by that logic, PA is equal to a. So by that logic, PA is equal to a. So we got two different lengths for PA. So let us equate them. H square plus k square minus a square is equal to a. Squaring on both sides, h square plus k square minus a square is equals to a square. So h square plus k square is equal to 2a square. And this is what we have to prove. All right. So I hope this is clear. So if you have any queries, feel free to write them down in the comment section. So let us move to the next question. From any point on the circle, so this is the circle given. So circle 1, let us say this is C1. Outer circle is, let's say this is the outer circle C1. So C1, center of the circle is minus G comma minus F. Every time you see an equation, try to write the center and radius of those circles and draw a figure. All right. And radius is square root of G square plus F square minus C. Now there is another circle given, this one. For this circle also, center is minus g comma minus f. So these two circles are concentric circles. Alright, they have the same center. Now we have to find out the radius. So after finding out the radius, if C2 has smaller radius, it will sit inside C1. If C2 has bigger radius, it will go outside C1. If C2 has bigger radius, it will go outside C1. Alright, I have already calculated. So that is why I have already made the diagram here. So let us calculate the radius. Radius is square root of g square. So g square is this thing plus f square minus c. C is this whole thing here. Alright. So that is minus c sine square alpha minus g square cos square alpha minus f square cos square alpha. So this is the radius. If you take these two terms, it is g square into 1 minus cos square alpha, which is sine square alpha, plus if you take these two terms, it will be f square into 1 minus cos square alpha. It will be f square into 1 minus cos square alpha, which is sine square alpha. And finally this term minus c sine square alpha. Sine square alpha is common from all the terms. So sine alpha into square root of g square plus f square minus c. Now if you observe, the radius of c1 is g square root of g square plus f square minus c, and this radius of this thing is c2 is square root of g square plus f square minus c multiplied by sine alpha. Since sine alpha is always less than 1, we can conclude that the radius of c2 is smaller than radius of c1. Therefore c2 lies inside c1 with the same center. So we have found out the radius. So let us erase this part. Now what do we have to do? So what are they telling? From any point P on the circle C1. So this is, let's say this is point P. Tangents are drawn to the circle C2. So these two are tangents. This is T1, this is T2. Then find the angle between the tangents. So let us say the angle between tangents is theta. So now we have the radii of both the circles. Now consider this particular triangle. So let this be R2. Let this length be R2. This length will be this length be R1. So this is R2 and this is R1. And in this triangle, this angle will be theta by 2 because of symmetry. Theta by 2. Now, since that is a right angle triangle, since this particular triangle is a right angle triangle, you can take sine theta by 2. Sine theta by 2 is equals to R2 upon R1. So that is simply sine alpha square root of g square plus f square minus c divided by square root of g square plus f square minus c. This and this will get cancelled. So sine theta by 2 is equal to sine alpha. This implies theta by 2 is equal to alpha. But we have to find out the angle between tangents. So that is theta. Theta is 2 alpha. Alright. I hope you have understood this. So the next concept is equation of a chord bisected at a given point. So you have a generic circle and there is a chord. The endpoints of the chord are A and B, and C is the midpoint of this chord. Now, if C is given to you, how do you find the equation of this particular chord? Alright, here C is given to you and you have to find the equation of the chord. The midpoint of the chord is given and you have to find the equation of the chord. So now let us start. Let the center will be minus g comma minus f. Alright. If you join the center and the midpoint of the chord, the angle will be 90 degrees and these two lengths will be equal. So this is a basic fact from high school which you should know. Alright. Now the slope of this green line, slope of green line will be y1 plus f upon x1 plus g. Then slope of chord AB will be minus of x1 plus g upon y1 plus f. Alright. Now we got the slope of the chord and we also know the point on the chord. So use the point slope form. So y minus y1 is equal to m into x minus x1. Alright. So this is y minus y1 multiplied by y1 plus f is equal to minus x1 plus g into x minus x1. Alright. So this is y1 plus yf minus y1 square minus y1f is equal to minus xx1 plus x1 square minus gx plus gx1. Alright. So this is the equation of the chord. Let us rearrange it a bit and see what we'll get. So we'll simply get xx1, so this term is done, plus y1, that is also done, plus gx plus gx plus gx plus yf is equals to x1 square plus y1 square plus gx1 plus yf1. So now what I'll do is I'll add gx1 on both sides. So xx1 plus yy1. So this will be gx plus gx1. I'll also add yf1 on both sides. So this is y plus yf1. This is equal to x1 square plus y1 square. Since I'm adding gx1 here, so this will become 2gx1 plus 2yf1. Alright. Now I'll add c on both sides. So this is c. Now if you carefully observe, so this is simply s1. Put x1 y1 into this and you will end up getting this. This is simply s1. And again, if you carefully observe this, this is simply t. So xx1, y1, g into x plus x1, y into f plus f1 plus c. So this is simply t. So t is equal to s1 is the equation of this chord when the midpoint of the chord is given. So if you did not understand what t and s are, go back to the second episode on this playlist and do check them out. Now let us proceed to the next concept, director circle. So what is a director circle? Let us say you have a circle and you are drawing two tangents from an external point to this particular circle. And now let's say the angle between these two tangents is 90 degrees. So the collection of all such points, all such external points from which you can draw two perpendicular tangents to the circle. So you might get some point, one more point here from which you can draw this kind of perpendicular tangents. So the collection of all these points will form a circle, and that circle is called director circle. We will prove that the locus is a circle and the name given to the circle is director circle. We will also find out the radius of the circle. Alright. So let us proceed. So I'll redraw the diagram. So this is your circle, and let us say you have two tangents like this, and the angle between these two tangents is 90 degrees. So this is T1, this is T2. So now the equation of T1, let's say we are writing the equation of T1. This can be written as y minus mx is equal to plus or minus a into root of 1 plus m square. Alright. Let's say the slope of this tangent is m1 and the slope of this tangent is m2. Now squaring on both sides, so you get y minus mx whole square is equal to a square into 1 plus m square. So this is simply m square x square plus y square minus 2mxy minus a square m square is equals to 0. Now let us say this point is h comma k. You have to find the locus of h comma k. So now this is m square h square plus k square minus 2m hk minus a square m square is equal to 0. Now if you carefully observe, this is a quadratic in m, and since it is given that the angle between the tangents is 90 degrees, we can write m1 m2 is equal to minus 1. So this quadratic equation will have roots m1 and m2. Now let us convert it into a good looking quadratic equation. M square into h square minus a square minus 2hk m plus k square minus a square is equal to 0. Now we know m1 m2 is equal to minus 1. So m1 m2 is simply c upon a. So that is k square minus a square upon h square minus a square is minus 1. So this can be written as k square minus a square is equal to a square minus h square. So h square plus k square is 2a square. So h square plus k square is equal to root 2a whole square. So if you observe, this is a circle with center 0, 0 and radius root 2a. So the director circle of this particular circle. So we have imagined the equation of the circle is x square plus y square is equal to a square. So only then you will have this particular equation as the equation of your tangent. So the director circle will be a circle with center 0, 0, basically a concentric circle, but the radius of this director circle will be root 2a. Alright, the radius of this director circle is root 2a. Understood? So this is the concept of director circle. So from any point on the director circle, if you draw two tangents to this circle, the angle between them will be 90 degrees. I hope you have understood this concept. So let us move ahead and solve a problem. So this is the next question. So you have a circle, alright, a circle is given. So the center, whenever you see a circle, just try to write the center. Center is 3 by 2 comma 2. And you have to find the equation of chord of a circle. Let us say there is a chord here. You have to find the equation of this chord. Let us say this is A and B, which passes through origin. So there is a point 0, 0 on this chord such that the origin divides it in the ratio 4:1. So this ratio is 4:1. So the ratio of this length to this length is 4:1. So this is the information given to us and we have to find the equation of this chord. So since it is given that the chord passes through origin, let us assume the equation of the chord as y is equal to mx. Alright. Now the circle equation is already given. So this is a very good question. Alright. Minus 4y minus 4 is equal to 0. The circle equation is given. So now if we substitute y is equal to mx into this circle equation, we will get these 2 points. Alright. So since the chord and the circle have 2 solutions, we'll get these 2 points. Let us do that. This will be x square plus m square x square minus 3x minus 4mx minus 4 is equal to 0. So this is simply 1 plus m square into x square plus minus 3 minus 4m multiplied by x minus 4 is equal to 0. If you observe, this is a quadratic equation in x. Alright. So it will have 2 roots, x1 and x2. So x1 will be the x coordinate of this point and x2 will be the x coordinate of this point. Let us say y coordinates are y1 and y2. Now x1 plus x2 is simply minus b by a. So this is 3 plus 4m upon 1 plus m square. And x1, x2 is c upon a. So this is minus 4 by 1 plus m square. Also, there is one extra information that is given in the question. So this ratio is 4:1 and this point is origin. Let us use section formula. So 4x2 plus x1 by 5 comma 4y2 plus y1 by 5 is origin. So compare the x coordinate and y coordinate. So you'll get x1 is equal to minus 4x2, y1 is equal to minus 4y2. Alright. Since we got x1 is equal to minus 4x2, let us substitute it here in this particular equation. So that will be minus 4x2 square, alright, is equals to minus 4 by 1 plus m square. So this and this gets cancelled. X2 square is 1 by 1 plus m square. Now let us put x1 is equal to minus 4x2 in this equation as well. So minus 4x2 plus x2. So that is simply minus 3x2. Minus 3x2 is equal to 3 plus 4m upon 1 plus m square. Alright. Squaring on both sides. So let us square it on both sides. Then we will get 9x2 square is equal to 3 plus 4m whole square by 1 plus m square whole square. 9x2 square is simply 1 by 1 plus m square. So this is 9 plus 16m square plus 24m divided by 1 plus m square whole square. This term and the square term get cancelled. So this is simply 9 plus 9m square after cross multiplication. So this is 9 plus 16m square plus 24m. This 9 and this 9 will get cancelled. So this will be 7m square plus 24m is equal to 0. So therefore m is equal to 0 or m is equals to minus 24 upon 7. Therefore your chord equation will be y is equal to 0, which is your x-axis, or y is equal to minus 24 upon 7x. So these are the two possible chord equations that you can have with the given information. Alright, so that is the solution for this question. I hope you guys have understood. So with this, we come to the end of this episode. If you like the content that I'm making, do share it with your friends. Subscribe the channel for more such content, and don't forget to like the videos. So if you have any queries about whatever we have discussed in this particular episode, feel free to reach out to me in the comment section. Even in case if you have any generic queries, feel free to write them down in the comment section. I'll meet you in the next episode, which will be episode 4 of the circle series. We'll bring more concepts to you guys on circles, and then we'll solve some problems there. Thank you. We'll meet you in the next video.